So today we're going to discuss the definition of function. In this course, we'll be working with functions and either graphing them for the purpose of giving a quantitative expression of a solution to an ordinary differential equation, or we'll simply need to approximate a function, and we have to all be on the same page. So the question, what is a function? We define a function as a rule that assigns objects from one set to another. This definition works across disciplines, but in mathematics, the sets are usually sets of numbers. So we write f goes from A to B. The arrow is a symbol for whatever the rule is. Do it. Take objects from A to B. So we typically mean little a is an object in the set A, and f of A is an object in the set B. Okay, so typically A is some subset of real numbers, and so is B. The set A is called the domain of the function f, and B is the range. The set f of A is the codomain. So if you picture the set A, all elements collected, and you map them with your rule, which you've labeled F, over to B, the target space, F of A would be the collection of elements that get hit. Another definition that folks like to use for function, a function is a mapping that assigns each element in the domain only one element in the range. It's very important to remark that only one element can be assigned in the range to elements coming from the domain. Okay, so this also results in some other characteristics that we have to point out. Okay, so the mapping F, the name of our function is little f, assigns to each element in A only one element in B. And we write, instead of saying all of that, F goes from A to B. And in our schematic, if we try to picture the elements in A, the mapping to B, we can say, well, I want this element to go here, this one to go there, this one here, and this one there. And this one can go over here. The points that get hit in B will become the codomain of the function f. What's important to note is that what is not allowed, so it's not allowed to say, well, this one I also want to get assigned to that value in B. You cannot assign more than one value to elements in the domain. So if we made the pink assignment, this would fail to be a function. The yellow assignments, though, would be a function. Even if you cannot write it down explicitly, it satisfies the definition of function, even though we've only given a schematic of what the function does. Now, most functions can be written down explicitly. So as an example, what I mean, if I write f of x is equal to 2x squared, this is the rule. It can be written down explicitly. The function assignment in yellow is a different rule. It just can't be written explicitly, but can be given schematically in a figure. Other things that we do with functions, we graph them. The domain is typically one of the axes and the range is the other. This assignment, at least, is followed for convention. When x is equal to 1, I'm at 2. When x is equal to 2, I'm at 4. And we have some kind of parabola that, at least here, is not fully drawn to scale. Another thing that we want to note is that to each value in the domain, I assign only one value in the codomain or in the range. Many of you learn the vertical line test. Each vertical line crosses the graph only once. This vertical line is checking, going back to the definition of function, that the assignment is so that each element in the domain is assigned to only one element in the range or in the codomain. Now, remember that your graph is a collection of ordered pairs, A, f of A. F of A is something that exists in the range. So there's quite a lot of things going on in a graph. If you're graphing a function, it will satisfy the vertical line test. That means that each vertical line crosses the graph only once. If you're ever drawing the graph of a function, you are not allowed to draw some kind of graph that fails the vertical line test. Then it would fail to be the graph of a function. And in most of my classes, we only care about functions. Any other drawing that is not a graph of a function could, result in some penalty. All right, so we've got the vertical line test, we've got graphs of functions, we've got an example of an explicit rule, we've got an example of an assignment given by some rule that I made up, but has no explicit form besides the picture. There's one more topic about a function that I want to address, and that is how do we call the variables? Usually we use variables in an explicit rule, and they each have a name. So the letter F is a name we chose for the function. In some ways, because this is a choice, you could say F is a variable, but it depended when an explicit rule is given, we choose an independent variable. Typically, the independent variable is x. We write f depends on x. This notation should not be confused with multiplication. There's no multiplication of f with x. This is a convention stating that f is a variable that depends on x. X is an independent variable. We sometimes say f is a dependent variable. Dependent variable. In our previous example, we wrote f of x is equal to 2x squared. You may write y is equal to 2x squared, and then proceed to graph. And remember that in your graph, in the graph of f, you collect all order pairs x, y, where y is equal to 2x squared. Most of this is done for conventions purposes, but really the letter y might be referred to as the dependent variable. The letter f would be referred to as the function. F and y would be considered interchangeable, so it would still be correct to write x, f of x, once the assignment has been made. What I want everyone to remember is that x is an independent variable. We chose it to be x, and y would be referred to as a dependent variable, or f would also be referred to as a dependent variable. We could write the same function as h of r is equal to 2r squared, or w is equal to 2r squared. Dependent variable, either w or h. Independent variable, definitely r. To me, these two functions, 2r squared and 2x squared, are the same function. The rule that defines them is the same rule. Simply the dependent variables and the independent variables have changed. Now, later in this course, we may also see parameters, a different kind of variable. But for now, we'll say that I assume everyone understands what a function is, how to identify their dependent variables, how to identify their independent variables, how to interchange names of functions, keeping the function unchanged, but the variables change. Let's go back to our example function, f of x is equal to 2x squared. You might be wondering, if functions are not allowed to assign one entry in the domain to two elements in the range, why is this still a function? This function has the property that f of 1 equal to 1 squared is equal to 2, and f of negative 1 is equal to 2 times negative 1 squared. that's also equal to 2. Why is this allowed? So remember, the rule is that each entry can only be assigned to one output. So every input gets assigned one output. The outputs are allowed to be shared. We saw that this graph still satisfies the vertical line test. Every vertical line will cross this graph only one time. Even though the inputs are the same, and even though the inputs are different, it's still true that they get mapped to the same place. This is allowed in a function. Okay. The ordered pairs on their graph are different though. We have the entry 1, 2, and the entry 1, -2. So we still have a legitimate graph. We still have a legitimate function. If I listed out all the real numbers here, they would get mapped to different places under F, and it's allowed that 2 different entries or inputs get mapped to the same output. This is still allowed under a function F, okay? So what isn't allowed is 2, so here's what you cannot do. You cannot make an assignment where F of A is 2 things at the same time. That's not allowed. But you can send 2 different entries to one same output, okay?